Okay, so this is a quick run through of fractions, just reminders of the basic rules. So we start off with a times fraction problem, 2/3 times 3/4. Well, when we're timesing fractions, then we simply times the denominators, 2 times 3, we times the numerators, 3 times 4, so 2 times 3, 3 times 4. The question said give it in simplest form, so we must remember to always check if there's a common factor. In this case, the highest common factor of both the numerator and the denominator is 6. So if we divide both numerator and denominator by 6, we get an answer of 1/2. So again, when you're timesing, there's no changing of denominators into common denominators or anything. So we just simply times the numerators and times the denominators and then cancel down if we need to. Now, when we're adding fractions, this can only really be done when you've got common denominators. So we can take out the whole number parts to start with. So we know the whole number parts will add to 3, and then we are left with the 2/3 plus 3/4. Well, when we're adding fractions and taking away fractions, we do need a common denominator. So we're going to make the lowest common multiple of 3 and 4 is 12. So we're going to turn 2/3 into 12ths, and we're going to turn 3/4 into 12ths. Well, the 3 to become 12 we multiply by 4, so we have to multiply the numerator by 4 as well. And the 4 to become 12 we have to multiply by 3, so we do the same to the numerator, so 3 3s are 9. Add those together and we get 17/12ths. Well, when we're finishing off our answers, we should always deal with mixed numbers if we've got improper fractions like this. So how many 12s go into 17? 1, so 12/12ths is a whole one. That leaves us with 5/12ths left over. We can then combine the two answers that we had from the whole parts originally plus the fraction parts. That gives us a final answer for this question of 4 and 5/12ths. Part C, it's a multiplication problem again, but we've got mixed numbers. So the best way to do this, is not the only way, but the best way is to turn them both into improper fractions, and then we can do the simple multiply the numerators, multiply the denominators, and then cancel down if we need to. So the first one talks about eighths. Well, in a whole one there's 8 eighths plus an extra 7 eighths makes 15 eighths. And in 5 1/3, well, in each whole one there's 3/3, so in 5 whole ones there'll be 15/3 plus an extra third is 16/3. We're timesing. Now, just like before, we times the numerators, so 15 times 16, and then we times the denominators, 8 times 3, 24. Now 15 16s, 150 plus 15 6s, 60, 90, 240. Divide by 24. Well, when we cancel this down, how many 24s go into 240? It's 10 exactly. So the answer to this one will be 10. Now when we're dividing fractions, again, it's better if both the fractions were in improper form, so one number on top of another one. So 3 1/2 is 7/2, and 2 4/5 is 14/5. Now when we're dividing, we have to remember that it's not easy to divide, so we take the reciprocal of the second fraction and multiply. So we end up doing 7/2 stays the same as the first fraction, and we end up multiplying by the reciprocal of 14/5, which literally means we flip the fraction over to become 5/14. Again, this now becomes the classic multiply, no change in the denominators. All we've got to do is 7 5s are 35, 2 14s are 28. This one will cancel down by 7. It's got a common factor of 7 to both the numerator and denominator. So 7 into 35 is 5, 7 into 28 is 4. We've got 5/4, which is improper, so we turn it into a mixed number. So how many 4s in 5? One whole one, and we're left with 1/4 over. So the answer to the original problem is 1 and 1/4. So the key ideas are that when you're adding and subtracting fractions, we use common denominators, and if we're timesing and dividing, we do not change the denominator at all. We just follow through the process of turning a division into a multiplication, and then the multiplication becomes numerators multiplied together and denominators multiplied together, and then cancel down if you need to.